If you vibrate at the natural frequency of air, your body, your cells will be in a state of excitement that should allow you to phase right through that wall, leaving the bond on the other side.
The Flash can do more than just run at lightning speed. He can also phase through walls, an ability he calls phasing.
We walk through the door. Shh. Yes, it's okay. It's called phasing.
The Flash isn't the only one who can do this. Many other superheroes can as well. So, can this superhero ability be explained by science? Of course, no human can simply walk through a wall without destroying it. But the story changes if you look at it from the perspective of atoms and molecules, because a solid object isn't always what it seems.
You look in close, all the molecules, if they're atoms, it could be atomic, they're all vibrating.
Water expands and becomes less dense if cooled below 4 degrees.
It takes a long time to train your body to be able to speed up whilst your molecules slow down enough to pass through the molecular structure of solid objects.
Let's start this discussion with a simple question. Why can you pass your hand through water, but not through ice, even though both are made of the same substance? If the answer is just that ice is denser than water, there's a strange thing you might not realize. Ice floats. If ice were denser than water, shouldn't it sink? This is where you need to know that water has an unusual property called the anomaly of water. Generally, when a liquid solidifies, it becomes heavier than its liquid form. But this doesn't happen with water. When its temperature drops below 4 degrees Celsius, water actually becomes lighter. As a result, the coldest water rises to the surface and ice will float. This means that when water becomes ice, it is actually less dense.
While most liquids contract and become denser, water expands and becomes less dense if cooled below 4 degrees.
This shows that something is solid or hard not because it's dense or compact, but because of something else. To understand this, let's talk about atoms and molecules. Everything physical in the world is made up of atoms, but atoms can't work alone. They must join together to form building blocks called molecules. You can imagine them like Lego pieces. These Lego pieces aren't all the same. Some are long, some are short, some are square, some are L-shaped, some are U-shaped, and so on. It's the same with molecules. Their shapes differ depending on the atoms that make them up. It's the molecules that make water, water, wood, wood, and iron, iron. You've probably heard that water is called H2O. It's called H2O because the water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. They are held together by a very strong connection called a covalent bond. This covalent bond is what keeps the water molecule intact, whether it's ice, a liquid, or steam. So what happens to water molecules that allows them to become ice, a liquid, or steam? Look at the shape of the molecule. An H2O molecule forms an angle. On one side, there are 4 electrons that are not paired with another atom. This causes that side to be more negative than the other, so the water molecule has a positive and a negative pole, just like a magnet. When water molecules are near each other, they can stick together and form a connection called a hydrogen bond. This is what makes water appear to be one continuous substance. However, hydrogen bonds are not as strong as covalent bonds. When water is in its liquid form, the molecules are always moving, which makes these hydrogen bonds easy to break. This is why water can be easily separated and your hand can pass through it. The condition is different when water becomes ice. You know that water becomes ice when it's cooled in a freezer, And you know this is because the freezer can lower the temperature to 0 degrees Celsius, which is the freezing point of water. The question is, what exactly is temperature? You might know it simply as hot and cold, but here's a definition you might not have heard often. Temperature is the average kinetic energy of the vibrations and collisions between atoms or molecules. You need to know that molecules are always moving, even in solid objects. The speed of this molecular movement is what you actually feel as hot or cold.
You look in close, all the molecules, or if they're atoms, it could be atomic, they're all vibrating. Are they vibrating fast? Are they vibrating slowly? Okay? You put a thermometer in there, that vibration gets communicated to the thermometer. The thermometer reads a temperature. It is the average kinetic energy, the average energy of motion of the vibrating particle.
What happens in a freezer is that it absorbs all of the water's kinetic energy, causing the water molecules to move slower and slower. When they reach 0 degrees Celsius, the water molecules essentially become still. When they are still, the hydrogen bonds between the water molecules become stronger than they were when the molecules were moving. That's what makes ice hard. You can see how the arrangement of water molecules changes when it becomes ice. Notice how the water molecules, which were previously moving freely, become rigid and bond together to form a hexagonal structure. Interestingly, if you look closely, this hexagonal arrangement actually makes the water molecules farther apart than they were in liquid form. This is what causes the anomaly of water. Ice becomes lighter. So, what's the connection between this phenomenon and the Flash's ability to pass through walls? From the explanation, there are 2 key points. First, an object is solid, not because of its density, but because the bonds between its molecules are strong enough. Ice is more solid than water because its molecules are more strongly bonded. Second, the more solid an object is, the harder it is for its molecules to move. This change from solid to non-solid, or vice versa, is called a phase transition. Remember the name of the Flash's ability?
Your body, your cells, will be in a state of excitement that should allow you to phase.
It's okay. It's called phasing.
I want to try that phasing thing. How do I do that?
Yes, it's phasing, a change in phase, like when ice melts. While we don't see the Flash melting, the point is that he speeds up the molecules in his body to change his body's phase from solid to non-solid. How does he do it? By vibrating. Why vibrates? You need to know that there are 3 types of molecular motion: vibration, rotation, and translation. Vibration is the shaking of atoms within each molecule. Rotation is the spinning motion of the molecule. Translation is the shifting of a molecule from its position. In a non-solid state, like water, molecules are free to perform all 3 motions. But in a solid state, like ice, molecules can only vibrate. If these molecules gain energy, like ice, when it's taken out of a freezer, their vibrations gradually become stronger. Eventually, the bonds within the molecules weaken until they break. This is what the Flash does. He speeds up the vibrations of the molecules in his body to weaken the bonds between them, making his body less solid.
If you vibrate at the natural frequency of air, your body, your cells will be in a state of excitement that should allow you to phase right through that wall, leaving the bomb on the other side.
At that moment, the Flash can easily slip each of his body's molecules between the molecules of the wall, just like water seeping into a wall. Once he's through, he slows his vibrations down again, and his body becomes solid once more.
It takes a long time to train your body to be able to speed up whilst your molecules slow down enough to pass through the molecular structure of solid objects.
That's how the flash passes through a wall. But the flash's method is inefficient because vibrating requires a huge amount of energy.
Are we always just sleepy and hungry and naked?
Vision, on the other hand, can do it without vibrating at all. He casually walks toward a wall and suddenly passes through it as if the wall weren't there. How is that possible? We'll get into the next topic, quantum tunneling, in a future installment. But before we end, let's return to the anomaly of water. Did you know that without this anomaly, we and all life on Earth could not exist? As discussed, water below 4 degrees Celsius becomes lighter, so the colder water rises to the surface. This is why ice only exists on the top layer in the polar regions. If you observe, the temperature gets colder toward the surface, but the water below is not as cold. This is what allows fish to survive even in very extreme weather. Without the anomaly of water, the fish would freeze to death. The layer of ice on top actually acts as a protector, like a blanket, because this ice layer cannot be penetrated by the weather above it.
Ice, being less dense, floats and covers the water body like a blanket. So a thick layer of ice on top insulates the underlying water from the frigid atmosphere.
That's for fish. But what's the benefit for humans? Why do the North and South poles exist for us? Because they keep Earth's temperature safe. Their vast ice layers reflect all the sun's radiation that is dangerous to humans. Without the polar ice, the Earth would be scorched.
In essence, it helps keep the planet cooler than it otherwise would be. So if we start melting away the snow and the ice, we're going to warm up faster.
That's why water was created with this anomaly.
Now you know how life on Earth owes a great thanks to the floating ice.